Right, my dear children. Now, in this chapter, we'll be studying about further things related with this electric current and how to use this ammeter things more conveniently, right? And how we can measure electric current in a circuit by using this ammeter or the milliammeter. And what kind of a thing is that? Series connection. Okay, right. So, first of all, you're given with an activity. In this activity, we are measuring the current flowing through a circuit. We are measuring the current which is flowing through a circuit. Right. To measure the current flowing through a circuit, you'll be needing these materials. Now, first of all, we need to make a circuit. So, to make a circuit, we'll be needing these instruments. See, torch bulb. Torch bulb. Then holder. You know, the bulb holder. Then wires. The most important one, to provide electricity, we need dry cells. And to identify the application or the use of ammeter and the milliammeter, right? We'll be needing definitely a milliammeter and an ammeter. So this is the ammeter. The milliammeter. So these are the instruments which we need in conducting this activity. A torch bulb, holder, some wires, dry cells, ammeter and a milliammeter. Right. So the method is also so simple in here. Here first of all, you need to connect the circuit according to the given diagram and connect the ammeter first. We need to connect the ammeter first and get a reading. Okay, we need to connect the ammeter and we need to get a reading from the ammeter. That's the first step. Then in the next step, we have to connect the milliammeter to the circuit and we have to get the necessary readings. So here we are comparing which instrument is more convenient or more easiest in measuring electricity in this particular circuit. Now you know that I told you that if you take a dry cell has very small amount of current, doesn't have like several amperes, right? Actually, my dear children, these ampere values are much larger. Right? Even in our household electric circuits. Household electric circuit means the electricity that we used in our houses, right? You know that electricity is very lethal. If you come in contact with that type of electricity which runs through our home, you may get injured due to electric shocks. So therefore, the electricity which is at your home, it has large amount of electric charges running through the connecting wires, right? So if you take a plug socket, right? If you take a plug socket at your home, normally it has maximum up to 13 amperes. Maximum up to 13 amperes. So that's in our household electricity. So you know that in a dry cell, the amount of electricity is very less. So even in the household electricity, we can find up to 13 amperes. So when we compare the amount of electricity with the household electricity and dry cell is pretty much lower. Means that we can't find at least 1 ampere of current within a dry cell. So my dear children, when we connect the ammeter into this circuit, it's difficult to get observations. It's very difficult to get observations. Okay? It's because that in a dry cell, the amount of electric charges or the electric current stored in a dry cell, the amount of electric charges in a dry cell, the amount of electric charges or the electric current stored is very much lower or fewer, right? So that's the main reason which we can't use an ammeter to measure electric current in a dry cell. We have to use the milliammeter. So here I'm going to show and prove you that. Okay. So how to do this activity then? First of all, we need to connect the circuit according to the given figure, right? So here, these two terminals, I'll name these two terminals. Here you can observe two connecting wires and there are two terminals, right? So I'll use like this. I'll disconnect this one, right? I'll disconnect this one, right? So I have disconnected the circuit. Now I am going to mark the two terminals as A and B. So this is terminal A and now this is terminal B. Okay, terminal A and terminal B. See? So first of all, you have to connect the circuit according to the given figure. Then for A and B terminals, first connect the ammeter, turn on the switch and get a reading. Okay. Then remove the ammeter, get the milliammeter, connect to the points A and B, turn on the switch, get the relevant reading. Okay. After getting two readings, compare which ammeter is more convenient to use, which ammeter is more easy to use, right? By that way, we can come into a conclusion, right? Okay, so we'll write down the method then. Connect the materials as per to the figure. Connect the materials as per to the figure. So according to the figure, we have to connect the materials. Okay. Then first connect ammeter to A and B terminals and get the readings. So this is the first step. First of all, you have to make the circuit according to the given diagram. Okay. Then after that, you have to first connect the ammeter to A, here A, and B, here B, A and B terminals, and get the readings. You have to get the readings. Then after that, connect the milliammeter to A and B, to A comma B terminals, and get the readings. So this is the way of doing the experiment. Okay, first of all, we have to make the circuit according to the given diagram. Keep two loose ends so that we can connect the ammeter and the milliammeter. Then after that, first of all, we have to connect the ammeter to the circuit for the two loose ends, A and B. Then after that, we have to connect the milliammeter to the circuit for A and B. Then once again, we have to take the readings carefully. We have to get the readings very carefully by using the ammeter and the milliammeter, right? Then we are going to compare which one is more easy to use. Okay, right. So this is the way of doing our experiment, right, my dear children? Now I am going to explain what do you mean by this series connection. So I told you that I am going to explain what do you mean by a series connection in this part. So let's identify what is a series connection. Now in this figure, you can observe the ammeter is in a series connection. This is what do you mean by a series connection in a circuit. It's really easy to identify. Okay. So how to identify a series connection? In a series connection, now I'm going to use circuit symbols to draw this circuit, my dear children. So this is our electric source, the dry cell. So it comes like this, and it's going to connect with a bulb, and it's going to connect with a switch, and once again it's going to connect with the negative terminal. I'll remove the switch. Okay, here I'll remove the switch. So we'll remove the switch. So this is my circuit. You know that in this circuit the bulb is going to light up. Now I need to connect the ammeter or the milliammeter. Okay, so we're going to connect the ammeter or the milliammeter thing. So how to connect this milliammeter or the ammeter? I'll use another bulb in here. Okay, so I'll use another bulb. In here I'll use another bulb, and here also I'll use another bulb. Right, so I'll name these bulbs as, this is B1, B2, B3. Right, B1, B2 and B3, the three bulbs. So my dear children, all of these bulbs are connected in a series connection. All of these bulbs are connected in a series connection. Okay, right. So series connection means, okay, series connection means it's like this. Now B1, B2, B3 are bulbs or electrical components, electrical instruments in this circuit. If these electrical instruments are connected to the circuit so that the electricity is going through one electrical instrument to another electric instrument, it's going through it. It doesn't have two identical, doesn't have two definite terminals. The electricity is going to pass one electrical equipment to the other. They don't have separate connections to the electric source. Right? What do you mean by a separate connection? It's like this. if it is going to have two or more separate connections, it would be like this then. I'll draw two bulbs. See, in that case, this is B1, B2, B3, the three bulbs. Check the differences between the bulbs in first instance and the second instance. So, my dear children, series connection, in a series connection, the electricity, you know that this is positive terminal and this is negative terminal. The electricity comes through the positive terminal, runs through B1 first. It's going to move through B1 first and going through B2. Right? Electricity is not going to pass all of these three bulbs at the same time. Right? It's because that these things are interconnected to each other. So, electricity should pass through B1 first and then it should travel to B2, then to B3. Right? And it comes back home to the negative terminal. This sort of a connection is called series connection. So, this is the one which is referred as the series connection, my dear children. See, series connection. Another way of identifying a series connection. Okay, I'm going to use my eraser and I'm going to show you. If I'm going to remove one single bulb from this thing, so now I have removed B1. The whole circuit breaks down. See, electricity will come and it couldn't travel to B2 because there is no connection between these two terminals if you remove B1. Right? So, in a series connection, if one electrical component breaks down, the whole circuit is not going to work at all. The whole circuit is not going to work at all. The whole circuit is going to break down like this in a series connection. Then there is another way of connecting, or there is another way of connection. This one in the second figure, it's called a parallel connection. Parallel connection. Series connection, parallel connection. So, I'll write it down in here. Parallel connection. Parallel connection. So, my dear children, in a parallel connection, if you take a parallel connection, in a parallel connection, for each and every electrical component in the circuit, they have a separate line of current flowing through the electrical source. See, now this is my plus terminal. This is my plus terminal and this is my minus terminal. So, this plus terminal is getting connected to this bulb B3. This plus terminal also going to run through B2 as well, and also it is going to B1 as well. So, this plus terminal is connected to all three bulbs in the circuit. But in here, I'll draw the B1 bulb once again to show you. See, B1. Now, check in here, the positive terminal is only connected to B1. It's only connected to the B1, no? See, it's only coming to B1. And through B1, it runs to B2. Through B1 it runs to B2 and to B3, then finally to B3 to home. B3 to home. Right? Finally B3 to home. So in here, the positive terminal is only getting connected to B1 and through that to B2 and B3. Negative terminal is only connected to B3 and through B3 to B1, B2 and B1. So there are no definite, right? There are no definite separate connections for negative and positive terminals. The current is flowing through B1 to B2 and to B3, my dear children. So this type of a connection is called a series connection. So if you disconnect at least one bulb in the circuit, the whole circuit, entire circuit is going to break down. Right? So it is called as the series connection. Series connection. So normally if you take during the season of Vesak, right, and Poson, I think you have come across with certain situations where you have to enlighten your home. I mean, like to light up your home, we use those light bulbs. So if there are some certain situations, if just one light bulb is going to remove from the system of light bulbs, the entire system or the entire light system is going to break down. Removing just one bulb is enough. Entire system breakdowns. It's because that all the bulbs in the system of that light is connected in a series connection. Right? It has a series connection. That's why when you remove just one bulb, the entire system is going to break down. Right? So my dear children, this is about the series connection then. The other way around is called the parallel connection. In a parallel connection, you can remove any bulb you want. Now I have removed B1 from the circuit. So even though I have removed B1, B2 still works because it has connected to the electric source from two separate lines. See? Positive, negative. So it's working. I'm going to remove B2 from the system. See, entire B2 now has been removed from the system. So in this case also you can observe the B3 is going to work. But in this case, if you remove only one, removing just one is enough. The entire system breaks down. See, current is not passing and the system will not work. Not even just a one light will work. It's because the current is not passing through the circuit. Here, if you take this system, this is a parallel connection, therefore you can remove any bulb you want. It is not going to affect the connection of the other or working or the not working of the other instrument. So these connections are referred as parallel connections. So parallel connection, series connection. These are the two types of connections that we can use to connect electrical equipments to a circuit. So ammeter always, so I'll use that circuit like this. So my dear children, in an ammeter, when connecting an ammeter, we need to use this series connection. We need to use this series connection thing. We have to use the series connection thing. Means that we need to disconnect the circuit and in between the disconnected terminals, we have to insert the ammeter. See? In the earlier case, see? I have disconnected the entire circuit and named the two terminals as A and B. I have connected the ammeter. So that connection is the one which is referred as the series connection, right? I'm going to show it to you when I'm going to do activities in the lab. Okay, so this is the way of doing our experiment, and I told you about what do you mean by a series connection and a parallel connection. So remember, always we need to connect an ammeter in a series connection, my dear children, right? Parallel connection is also important. We'll be discussing about parallel connection when you are discussing further things related with the lesson. Like when we are discussing about voltage or the potential difference, this parallel connection is helpful to us, right? We connect voltmeters in parallel connections. We will discuss these things later in the lesson, right? So my dear children, this is the way of doing, and this is the way of getting measurements related to the ammeter and milliammeter. So always remember, ammeters should be connected in a series connection, right? So here, once again, we'll see how to conduct this activity. So first of all, what you have to do, connect the materials as per to the given figure like this. So you have to keep two open ends to connect the ammeter and the milliammeter separately in a series connection. So first connect the ammeter to A and B terminals and get the necessary readings. Then connect the milliammeter to A and B terminals and get the necessary readings, right? So this is the way of conducting the activity. So we'll head on to the lab and we'll conduct this activity, and we'll see which ammeter is more convenient to use when taking readings in a smaller circuits like this. Right, my dear children. Now, in this activity, we'll be observing how we can measure the electric charges or electric current in a circuit. So to measure electric current in a circuit, we use the instrument called the ammeter. This is the one which is called as the ammeter. So here, the current is measured or current is marked in this thing. Here you can observe there is a sign for the ammeter, and the current is marked from amperes, right? Amperes. In the ammeter, the current is marked from amperes, right? So this is called as the ammeter, right? So in an ammeter, if you take an ammeter, in an ammeter we can measure somewhat heavy currents. Actually, heavy means somewhat larger currents. Okay, by using this ammeter thing, we can measure somewhat larger currents. But if what if there are very small bit of currents? Now in the earlier grades, like in grade 6 and 7, you have studied that we can generate some amount of electricity by using a lime fluid. So in that case, we can't measure the amount of electricity or the amount of electric current in that situation by using this ammeter. It's because that the current which is generated in that situation is very small. So to measure smaller currents in a circuit, we use this instrument which called as the milliammeter. Milliammeter. Here in a milliammeter, right? In a milliammeter, you can observe simple M and capital A in here, which stand for the milliammeter thing. And in a milliammeter, the scale is marked from milliamperes. Scale is marked from milliamperes, right? So to measure very small currents, we use the instrument called the milliammeter. To measure very small currents, we use the milliammeter. Now I'm going to show you how we can apply this ammeter and the milliammeter in two different occasions. So for that, I have arranged these materials and to prepare a circuit. So what I'm going to do is, I'm going to take the ammeter first. Now you can see that I have two dry cells with me, right? I have two dry cells with me, means that when you're providing two dry cells, it's going to provide some amount of an electricity, right? Somewhat not that much large, but still it's way more larger than this milliampere thing, right? So when I'm going to use two or more than dry cells, right, I'm going to use the ammeter thing. That's the more convenient one. We can't measure by using the milliammeter if I'm going to use several dry cells. So I'm going to use the ammeter first, and I'm going to connect this positive terminal with the positive end of the dry cell, right? Positive to positive always. And there's another case, my dear children. That thing is, when you're connecting an ammeter, always the ammeter should be connected in a series connection. Series connection means when you're connecting this ammeter, when you're connecting this ammeter, the current should flow through the ammeter and to the other instruments. It should travel through the ammeter like this and to the other instruments, right? So you can't directly connect like this. You can't connect directly like this, and you can't give a different connection to the other terminals like this. Always apparatus should go through the ammeter and they should travel back to the whatever the electric source. So that kind of a connection is called a series connection. So I'm going to show you how a series connection works in this thing also. Right now, this is my negative terminal. Then you can see the black color terminal. Now I have connected this positive terminal to the positive end of the dry cell. Now what I'm going to do is I'm going to take the switch and the bulb, right? Take the switch and the bulb. So I'm going to connect this negative terminal to the one end of the bulb like this. Okay? Means that when current is passing through the circuit, right? It goes through like this, and through the ammeter, through the bulb to the other one. So this kind of a connection is the one which is referred as a series connection. Means that current is passing through the ammeter to the other instruments and way back to once again to the negative terminal in a dry cell. That's how a series connection works. Right now, I'm going to take the other connecting wire which goes through the switch and which comes back again to the negative terminal of the dry cell. Right. Now, I'm going to turn on the switch and let's see how or what kind of a reading will the ammeter is going to give. Okay. Right. So I have turned on the switch. So here the reading is just moving to my right hand side, and it's very small, right? Here there are 10 divisions. From 0 to 1 there are 10 divisions. From 0 to 1 there are 10 divisions. Means that one each division, 0.1 amperes is one single division. So here you can observe from 0 the reading has traveled 1 and 2 smaller divisions. Means that the current passing from the circuit is 0.2 amperes. In this circuit, the current which is passing is equal to 0.2 amperes. Right? 0.2 amperes. So there are 0.2 amperes in the circuit. Right? Now I am going to disconnect the circuit. And the other case, when you are connecting these ammeters, remember there are two terminals which are referred as the positive and the negative terminal. In the earlier activity also I told you that in any kind of electricity measuring instrument there are two distinct terminals marked from red and black color. Red color one is the positive So red color terminal should always connected to the positive terminal of the electric source. Remember that thing. That's really important when you are connecting these instruments to the measuring instruments to a circuit. Right? Always the positive terminal should run to the positive terminal of the electric source. Now I am going to disconnect the circuit. Now I am going to take the smaller instrument or the smaller ammeter, which is referred as the milliammeter. When you take 1 milliammeter means 1 of 1,000. 1 of 1,000 from an ampere. Now I told you that when you take this ammeter thing, in an ammeter the reading is marked from amperes. In a milliammeter the reading is marked from milliamperes. So 1 milliampere means 1 of 1,000 from amperes. Right? When you divide 1 ampere by 1,000 units, when you divide 1 ampere by 1,000 units, you can get a one value of a milliampere. Okay, so here you can observe it's been marked up to here 100 milliamperes. 100 milliamperes. 100 milliamperes means 100 units of 1,000. Means in amperes this value is just 0.1. This is just 0.1. 100 milliamperes means just 0.1 of amperes. So when you take this thing, it's been marked from amperes, no? So 0.1 amperes means just one smaller division. Just a one smaller division. So when I am going to connect this circuit, you can observe the reading is going to travel. There are 3 divisions. You can observe there are 3 divisions now. So current in this circuit is 3 divisions now. 3 divisions means 0.3 of amperes. 0.3 of amperes. Now I am going to disconnect this one and I am going to connect this milliammeter to my circuit. So you know that I told you earlier, in this milliammeter we can measure only 100 milliamperes. 100 milliamperes means, my dear children, only 0.1 of amperes. So when I am going to connect this thing to the circuit, we can't get an exact measurement. The reading should run way back to the other end and we can't get a definite idea or exact measurement. It's because that in my circuit, in this circuit, I have 300 milliamperes or 0.3 amperes. But in this milliammeter, I have only 100 milliamperes, 0.1 of amperes. Now I'm going to connect and show you that we can't measure current in this circuit by using the milliammeter. So I'm going to connect this thing now. Positive to the red color one. See, red to red, positive to positive, negative to negative. Now I'm going to turn on my switch. This is the bulb here. I'm going to turn on my switch. Bulb should light up, but the reading should go over 100. That should be my observation. So can you check the reading? The bulb is going to light up and the reading is traveling way more than the 100 milliamperes. It's because that the current which is given from this circuit is very much larger to measure by using the milliammeter. So I'm going to disconnect, otherwise my milliammeter would break. So I'm going to disconnect. So what is the purpose of using a milliammeter then? So I told you milliammeter is being used to measure very smaller currents. So I have a button cell with me. See, I have a button cell with me. This is called as a button cell. These button cells are being used. These button cells are being used in washers, sometimes in smaller remotes, in AC controllers, right? These button cells are being used. So this is a button cell, and this button cell is also somewhat being used. Means that the amount of electricity in this button cell is very small now, right? So first of all, I'm going to use the ammeter, and let's see whether we can get a definite reading from the ammeter, right? So I'm going to connect. In these button cells, the positive and negative terminals are at up and down, right? So I'm going to connect it. There is a very small deflection, right? This deflection cannot be exactly measured as it is very small. See, we can't measure it clearly, right? It's because that this button cell is giving very small bit of a current. So if a very small bit of current is given, to measure that smaller currents, we use the instrument, the milliammeter. So now I am going to connect the milliammeter, and let's see how much is my reading, right? So here we go to the milliammeter. Let's connect and see. Now you can observe it's going to like 20, 25. So it runs up to 40. So this is the use of this milliammeter instrument. We can measure very smaller currents by using the milliammeter. To measure somewhat larger current, we use the other instrument called the ammeter. Ammeter, the scale is marked from amperes. In a milliammeter, scale is marked from milliamperes. 1 milliampere is 1 of 1,000 from 1 ampere. Right. So let's head on back to our classroom, and we'll observe what are the other things in the lesson. Right, my dear children. So we conducted the activity, and you could observe that it's really easy to use and get the readings by using the milliammeter rather than using the ammeter, right? When you connect the ammeter, the reading will move slightly. Even we can't get a clear reading by using an ammeter in this circuit. So it's difficult to use ammeter when taking readings in a small circuits like this. So observation is quite simple, my dear children. You could observe that both the ammeter and milliammeter, they showed some amount of or some kind of a reading, right? Ammeter moved slightly while the milliammeter moved somewhat more than the ammeter, right? So we'll write that observation. What's that? Milliammeter reading moved to get a clear milliammeter reading moved to get a clearer reading. But ammeter reading moved. Ammeter reading, I'll mention indicator as well, okay? Indicator. So but ammeter reading or ammeter indicator moved slightly. So millimeter reading or the indicator moved to get a clearer reading, right? So it moved to get a very clearer reading, right? But the ammeter reading moved slightly. Ammeter reading moved very slightly. We can't get a clearer reading. So our conclusion is finally, right? Our final conclusion, ammeter can be used to measure large current. Measure large current. Ammeter can be used to measure large current. Milliammeter can be used to measure small currents. So this is the use of ammeter and the milliammeter. So we can see that milliammeter can be used to measure smaller currents, while the ammeter can be used to measure large currents, right? So there was another thing called, you could observe that there was another thing called the microammeter, right? So microammeter is even more smaller than the milliammeter thing, my dear children. Now microammeters means to measure very smaller currents, we use the thing called microammeters, right? To measure very smaller currents, we use the microammeter, right? So in normal laboratories, we can't identify or we can't find out these microammeters, because there, when you take normal circuits, if you measure the amount of electricity or electric charges, so it has some amount of a electric charge. I mean, like we can measure it by using milliamperes. But if you measure it through microamperes, it will be much heavier, right? So we can't get a direct answer, like the reading will move and it will hit on the edge of the microammeter, and we can't get a clear, more effective reading. So microammeters are not being used normally in laboratories, in our school laboratories. Okay, so my dear children, so this is the use of ammeter then. So always remember, these ammeters, when you connect in these ammeters should be connected in a series connection, right? The connection type should be series connection. Series connection is the one which we use to connect an ammeter or else a milliammeter to a circuit. So my dear children, this is all about with the electric current, how to measure electric current, the equipments that used to measure electric current, and the units, and about the symbols, and so on. So I told you, if you take household electricity, in household electricity plug sockets, the highest amount of current that can be obtained is up to 13 amperes, right? But in sometimes, this is in sometimes, okay, not all the times. Sometimes, my dear children, the current is being given like this. So if you have observed some rechargeable dry cells that are coming up with mobile phone batteries, right? And I think you have heard the power banks, the term called power banks. We use power banks to recharge mobile phones or mobile devices. So my dear children, sometimes you have observed in those power banks, there is a term called 2000 mAh, sometimes 20,000 mAh, sometimes 10,000 mAh. Now, in a normal dry cell, right? In a normal dry cell and in a normal circuit, you know, we measure currents by using the term called this thing we know. What is that? Milliamperes. That's milliamperes. MA means the milliamperes. So sometimes in rechargeable dry cells, you know that if you take these power banks, we can recharge the power bank and can be used several times. So these ones also sometimes been printed as like this, 4200 mAh, right? So what do you mean by this mAh? It refers to milliampere hours. Milliampere hours. So here 2000 milliampere hours means we can use this dry cell, right? We can use this dry cell, right, up to 2000 hours, up to like 2000 hours. If it is providing, or if 1 milliampere of a current is being drawn out from the dry cell. Okay. For a simple example, I'll use this dry cell, this one. Here it's been printed 4200 mAh. I'm going to connect it with an LED. Like this. Now you know that LED will light up. Okay. So let's imagine when this circuit is going to work, this LED will take only 1 milliampere. So when this LED is going to work, I mean like when it is going to light up, it's consuming only 1 milliampere of a current. So if you connected with this dry cell, right, this rechargeable dry cell, you can light up this LED up to 4200 hours. That's what do you mean by this 4200 milliampere hours. If the amount of current given at a certain instance is 1 milliamperes, then we can use this for 4200 hours of a time period, right? So sometimes you will come across with these values as well, right? mAh values. We use these mAh values to indicate the unit called milliampere hours. Okay, it's not the current. Here it's not providing 2000 milliampere of a current. Okay, remember it's saying about the amount of time or the time period which the dry cell or the battery or the current which can be used, right, when operating electrical equipments, right? Here the idea of 2000 mAh means if 1 milliampere of a current is being drawn out from the dry cell, then we can use this dry cell for about 2000 hours. Okay, so don't get confused with the milliampere hour thing and milliamperes. Sometimes in heavy batteries, like in lead acid accumulators, it's given in ampere hours, Ah, right? It's given in ampere hours. Okay, so that's how these dry cells and these batteries are being marked with the amount of electric current. Okay, so the amount of electric current most of the times in heavy dry cells and heavy batteries being marked as milliampere hours relative to the time period which it's going to work. Okay, but in normal dry cells, right, in normal dry cells like the dry cells that we use to insert in our remote controllers, dry cells that we used in our flashlights, torch, right, in those type of dry cells, right, even the amount of electric current is not given, we have to measure it out. Okay, but most of the heavy batteries and dry cells, their time period is given relative to the current which is getting produced. Okay, my dear children, so this is all about with the current and how to measure current. So I hope that you got a sound knowledge about how to measure the current and how to connect these ammeters and milliammeters to a circuit. And I have given you what does this milliampere hour thing means in different types of dry cells and batteries. Okay, so in the next chapter we'll discuss further things related with the lesson.